Assalamualaikum and greetings to Dr. Aino and anyone else that currently watching this video. So for the video presentation Basic Analytical Chemistry, we would like to discuss about mastering the art of titration, which is a step-by-step guide. Before we begin our video presentation, I would like to introduce our team members. So we have 4 members which are Haikal, me, Wanas Linda, Shahrul and Haziq Nasrullah. First thing first, we would like to begin by expressing our gratitude to Allah the Almighty for blessing us throughout our research and enabling us to successfully complete this video presentation. We would like to thank Dr. Aino Awanis binti Muhammad Badiah Zaman for giving us the opportunity to work on these assignments. We are grateful for her contributions and guidance throughout the semester, which greatly assisted us in completing this video presentation. It was an honor to work under her supervision. We would also like to extend our thanks to our family and friends for their constant inspiration, support and guidance during the completion of this assignment. In this video, we would like to figure out 6 things which are introduction, apparatus, methods, application and indicator shows the equivalence point in a titration by reacting with an acid or base, and lastly is the conclusion.
Let's begin with the introduction. So, titration is a process of chemical analysis in which the quantity of some constituent of a sample is determined by adding to the measured sample an exactly known quantity of another substance with which the desired constituent react in a definite known proportion. So, the purpose of titration is to determine the concentration of a substance by reacting the substance with another substance of non-concentration in a reaction. There are a few apparatus that we need to do the titration. So the first one is the burette, funnel, pipette, beaker, graduated cylinder, conical flask, and the lastly is the retort stand. So there are a few methods or steps that we need to follow to do a titration. The first one is we need to fill the burette with the solution and record the initial volume. Our right hand is hold and spill the flask, while the left hand we need to control the stopcock of the burette. After that, we need to place the burette deep in the neck of the flask while we swill. And we can place the flask on a white tub. After that, we can start the titration. Introduce the titrant in increment of 1 milliliter. Decrease the size of increments as the titrant progresses towards endpoint. And lastly, we need to record the final volume to the nearest 0.01 milliliter.
Titration is a versatile analytical technique with broad applications across various industries. In the pharmaceutical industry, it ensures the correct concentration of active ingredients in drug formulation, maintains quality control by checking the purity of raw materials and finished products, and determines the pH of solutions crucial for drug stability and efficacy. In the food and beverage industry, titration helps determine levels of vitamins, minerals, and other nutrients, measures the acidity in products like wine, beer, dairy, and juices for taste and preservation, and assesses salt content to meet health standards and taste preferences. For environmental monitoring, titration measures the concentration of pollutants such as heavy metals and organic compounds in water bodies, determines the acidity of rainwater for environmental impact assessments, and measures soil pH and nutrient content for agricultural planning and conservation. Industrial applications of titration include ensuring the correct concentration of chemicals in manufacturing processes for product quality and safety, measuring sulfuric acid concentration in lead-acid batteries for optimal performance, and determining the corrosive properties of substances for material selection and protection.
So guys, next we will talk about an indicator shows the equivalence point in a titration by reacting with an acid or base. First of all, we must know the function of indicators. First is color change. Indicators are chosen because they change color at the pH corresponding to the equivalence point of the titration. Next is selection of indicators. It depends on the pH range of the equivalence point. For example, phenolphthalein change from colorless to pink at pH 8.2 until 10 used for strong acid, strong base titrations. Next is methyl orange. Change from red to yellow at pH 3.1 until 4.4, and it is used for strong acid weak base titrations. So guys, after we know the function of indicator, so let's we know how they work. First is addition of indicator. A few drops of indicator are added to the solution before titration. Second is titration process. The titrant is gradually added to the analyte solution. Third, observation of color change. After titration nears the equivalent point, the solution pH change, causing the indicator to change color. And four, endpoint detection. The first permanent color change indicates the equivalent point has been reached. So, after we follow how they work, we can get a good titrant when we do an experiment. So, for the last part of an indicator shows the equivalent point in a titration by reacting with an acid or base is visual example. First, before equivalent point, the solution remains initial color. It is because due to the unpresent of an indicator or the intrinsic color of one of the reactants. Second is at equivalence point. The color suddenly change. It is because this is the point in a titration at which the amount of titrant added is exactly enough to, to completely react with the analyte in the solution. At this point, the solution's pH change significantly. Last, after equivalent point, the color stabilizes in the new form. After the equivalent point, additionally, titrant change the pH significantly, often beyond the range where the indicator change colors.
Importance of titration in food analysis. The purpose of titration in food is to ensure balanced composition of food products. For example, measuring salt content in canned vegetable using manual titration. The method used for titration is, for the titrant, we use silver nitrate, AgNO3, and for analyte, use sodium chloride, NaCl. The silver nitrate and sodium chloride will react in a 1:1 molar ratio. The procedure before the titration begin. Calculate the concentration of silver nitrate to use in the titration. Next, measure the volume of silver nitrate to titrate sodium chloride. After that, use stoichiometry to find sodium chloride concentration. Importance of doing the titration is to prevent excessive salt in canned product, high sodium intake risk, for example, high blood pressure, stroke, and heart disease. And lastly, titration is crucial for food safety and health. In conclusion, titration is an essential technique in chemistry used to determine the concentration of a solution. It involves carefully adding a known solution, the titrant, to an unknown solution until a chemical reaction reaches its endpoint. By measuring the volume of titrant required, we can calculate the concentration of the unknown solution.